Good afternoon, everyone. And hope you are just revising the yesterday's classwork notes. You have notes along with you. Few important points to be noted. Okay. And here is what we have on the screen. Fine. Okay. Now have a small request. Is the board clear?
Yes, ma'am.
And is the voice clear as well?
Yes, ma'am.
Okay, then we'll go ahead. So yesterday we were talking about the electrode potentials and its calculations, and we have discussed that we are talking about the galvanic or voltaic cells, which will produce net electrical energy, okay, because of flow of electrons from anode to cathode. The reactions are spontaneous, and we have come to the point that to know the net EMF a particular galvanic or voltaic cell can produce, I can have the mathematical expressions. E cell is equal to E cathode minus E anode, or E cell is equal to E right minus E left electrodes. This while considering the reduction potentials of the electrodes. Okay. By this time, I hope you are all clear with the point. What does SRP value say? SRP value means standard reduction potential. That means it is the electrode potential which gives the reduction values of a particular reaction. Okay. This same can be written as E cell is equal to E anode minus E cathode when I'm considering oxidation potential at anode. Okay. Hope you know that whenever I'm addressing the word cell, it is a combination of anode and cathode. And at anode, there is always oxidation taking place, which is nothing but loss of electrons. And at cathode, reduction takes place, which is gain of electrons. No matter whether it is a galvanic cell or an electrolytic cell. Okay. And in galvanic or voltaic cells where there is net electrical output, that is cell reaction taking place is spontaneous. In such cases, what you'll have anodes being negatively signed or charged and cathodes being positively charged, which is exactly opposite to the electrolytic cells. Okay. And so after realizing that the two electrodes placed should give net electrical energy, okay, and to calculate them, I've already given that a series called as the EMF series, which includes SRP values of various metals and non-metals, would help us to realize whether a particular cell reaction is spontaneous or non-spontaneous, or how much electrical output I can get from those two combination of the electrodes. Okay. And anytime I want to show that a particular electrode is acting as anode and a particular electrode is acting as cathode, I'll always give the cell representation or cell notation, where I've shown there M/Mn plus C1 /Rn plus C2/R is the cell notation, which is the simplest to express which is acting as anode and which is acting as cathode. And we know that by default, anode is always on the left hand side and cathode is on the right hand side. Okay. Is the point clear? Okay. Now I'll just go ahead. Okay. నిన్న అర్థమైపోయింది కదా ఈ సెల్ వాల్యూస్ ఎలా క్యాలిక్యులేట్ చేస్తాను అని చెప్పి. సరే. ఓకే. సో ఈ సెల్ క్యాలిక్యులేషన్స్ ఎలా చేయాలో నాకు అర్థమైన తర్వాత ఎందుకు అసలు నేను తెలుసుకోవాలి ఈ సెల్ గురించి అంటే నా టార్గెట్ ఏంటంటే నాకు స్పాంటేనియస్ కెమికల్ రియాక్షన్ నుంచి ఎలక్ట్రికల్ ఎనర్జీ కావాలి. దాని కమర్షియల్ అప్లికేషన్ తెలుసు, బ్యాటరీస్ అని చెప్పి. సరే, సో అయితే ఒక ఎనీ టూ ఎలక్ట్రోడ్స్ ని కంబైన్ చేసేయగలనా లేదా? చేయలేను. ఎందుకు అంటే నాకు ఎప్పుడు మాక్సిమం అవుట్పుట్ కావాలి. ఈ సెల్ నాకు ఎప్పుడు టార్గెట్ ఏంటి, ఎక్కువ ఉండేటట్టు ఉంటే ఇట్ ఈస్ అ బెటర్ బ్యాటరీ, అంతే. సో అది ఎలా తెలుసుకుంటాను? ఆ ఫార్ములా యూస్ చేసి క్యాలిక్యులేట్ చేసుకుని తెలుసుకుంటూ ఉంటా. సరే, అయితే ఇప్పుడు ఒక పాయింట్ ఐ నీడ్ టు కమ్ డౌన్ టు వన్ పాయింట్. ఓకే, హౌ టు క్యాలిక్యులేట్ and how to represent. That's what we have just done. Okay, now if I say, can you apply this to Daniel cell? Right. So write the question. Good afternoon, everyone there. Write the question. Give the cell notation. And calculate E naught cell value. And calculate E naught cell value of Daniel cell. Given E naught Zn plus 2 slash Zn is SRP values. I'm giving the SRP values. Kids, just look here. E naught Zn plus 2 slash Zn is equal to minus 3.4 volts. 0.76 volts. Minus 0.76 volts. And E naught copper plus 2 slash copper is equal to plus 0.34 volts. What you need to write? This is given. What you need to do? This combination is nothing but a Daniel cell. You need to write cell notation and you should calculate E naught cell because both are under standard conditions. I'll give you 1 minute or 2 minutes time. Please go ahead. Easy.
One point one, ma'am.
1.1 volt. That's your answer. Okay. Let me rub the board. Did you write the cell notation? Now this is my problem, very practically. I don't know exactly how many of you are able to write it, but one point I need to tell you all. This is perfectly best way of learning, actually. How sincere you are, how confidently you can crack new topics. If something might be not known to you, okay, no problem, we are learning it right now. Okay, did you write the cell notation? Okay, right. Question number 2. Those who have not done, get up. Those who have already done, please take down the next question. Okay, next bit. Write the cell notation and calculate E naught value. Write the cell notation and calculate the E naught value. And calculate the E naught value of the following cell. E naught copper, E naught copper, that is, you need to write whenever I say E naught copper means E naught Cu2 plus slash Cu is equal to plus 0.34 volts. E naught silver. E naught silver, that means Ag plus slash Ag is equal to 0.8 volts plus 0.8 volts plus 0.8 volts. Write the cell notation and calculate. Write the cell notation and calculate the E naught cell for the given combination. Okay. Have you done that? Oh.
Point 0.46 ma'am.
Plus or minus R?
Plus.
Plus R. Okay. You have done that. I hope everyone have done it confidently. It's all very easy. Only when you make it easy for yourself. Okay. So it's again, it's about clear. Danger, and it is legible to you all. Okay. Now I'll get back. So I've asked for the first one. Okay, that is the Daniel cell. So what are the two electrodes I've chosen in Daniel cell?
Zinc and copper, ma'am.
Zinc and copper.
Zinc and copper. And whenever, what all I always tell, whenever you're saying E naught value, if not specified, I would always write as Zn plus 2 slash Zn is equal to minus 0.76 volts. And E naught of copper is plus 0.34 volts. Okay, how to write the cell notation, how to calculate E cell value. So if I say E cell calculation is pretty easy, that will again be E naught cell. E naught cell will be equal to E cathode minus E anode, that is going to be, what is cathode value? 0.34 minus of minus 0.76, that is equal to 1.1 volt. I hope you got the same. Very easy. Okay. Now how to write the cell notation, which is anode and which is cathode? If SRP values are given, which will be anode and which will be cathode? Are you able to say?
SRP
Anode
cathode.
will be zinc, ma'am. Cathode will be copper.
More SRP value,
Low
cathode.
SRP value.
Whose SRP value is less, that is going to be anode. Whose SRP value is more, that it's going to act as cathode. Okay, now I'll represent. Okay, anode is negative. Always anode oxidation. So Zn solid. Zn plus 2. What I should write here? Concentration. E naught condition. E naught condition means what should be the temperature and what should be the concentration of the
Molar.
electrolyte? 25 degrees centigrade and 1 molar. So I can straight away write as 1 m. It is, they are separated by salt bridge. Next, copper plus 2 is undergoing reduction. Again, E naught condition, therefore 1 m slash copper. This is the cathode. Okay, that's a very easier one. Easiest, I suppose. Okay, then I've given the other one. Okay, what's the other one? What's the other combination? I told you.
Silver, copper.
Silver, copper. Now here, can I presume that here in this case, E naught cell is equal to plus 1.1 volt? Is it correct? Yes, it is correct. Okay, next I took the combination of copper and silver. Now can I combine these two electrodes and make and I bring about a galvanic cell. Okay, so the second question was, it was given that E naught value of silver electrode is plus 0.8 volts and that of copper is plus 0.34 volts. Okay, now I have to write the cell notation and calculate E cell. So E naught cell will be equal to E naught cathode minus E naught anode. That's going to be 0.8 minus 0.34 volts. Okay. ఏదైనా SRP వాల్యూ ఎక్కువ ఉంది 0.8, ఏది కాపర్ తక్కువ ఉంది ఎంత? What's the answer? What's the answer?
0.46.
0.46.
0.46 volts. Plus or minus?
Plus.
Plus. Okay. How to write the cell notation? Which is anode and which is cathode?
Anode copper, cathode zinc, silver.
Okay. Cu slash, that is negative, solid, Cu2 plus 1m double slash silver plus 1m slash silver plus. That's a cell notation, right? Did you get the same?
Yes, ma'am.
Yes. Okay. Now, right. Given right. Write the cell notation. Write the cell notation. Write the cell notation and calculate the E cell value. And calculate the E cell value for the following electrodes. For the following electrode. Right. E naught, iron, E naught iron, that is Fe plus 2 slash Fe is equal to minus 0.44 volts, minus 0.44 volts, and E naught lithium, that is Li plus slash Li is equal to minus 3.05 volts. Have you done that? Again. Two positives you have taken. Now it's my question of, that's the third one. Okay. So what is given? E naught Fe plus 2 slash Fe is equal to minus 0.44 volts. and E naught of Li plus slash Li is equal to lithium is equal to minus 3.05 volts. Therefore, E cell, E naught cell is equal to E cathode minus E anode. Now, which is cathode and which is anode?
Cathode iron, anode
Cathode
lithium.
iron.
Cathode iron, lithium.
Why you take cathode as iron?
Highest
Lithium
RPM.
and
Hmm?
High,
Why
highest
lithium is
Highest
anode?
RPM, ma'am.
Yes. Okay. Lithium has the least SRP value. It always acts as anode and undergoes oxidation. So I'll get back to the equation. What is the cathode here? Iron is the cathode, minus 0.44. Minus of minus 3.05 volts. That's going to be
2.6.
0.308 minus
2.6.
0.44.
2.61.
2.61 volts. Okay. And how to write the cell representation? Minus Li solid slash Li plus 1m double slash iron plus 2 1m slash iron. This is going to be positive. This is solid. That's a cell representation. And by this time you're clear that I'm not writing the cell reaction. Why? I'm not concerned about the stoichiometry because all are at 1m concentration. Therefore, standard single electrode potential is independent of the stoichiometry of the reaction. Okay, that's an important conclusion we can draw. Okay, అర్థమైందా చెప్పేది? ఏం చెప్తున్నాను? ఒకటేమో +2 నుంచి ఒకటి 0కి వెళ్తుంది, ఒకటి Li ప్లస్ నుంచి Li నుంచి Li ప్లస్కి వెళ్తుంది, అంటే ఆక్సిడేషన్. ఇక్కడ మనం స్టాయికియోమెట్రీని ఎందుకు కన్సిడర్ చేయట్లేదు? ఎందుకంటే అన్ని 1m కాన్సన్ట్రేషన్ లోనే ఉంటాయి. సో స్టాండర్డ్ కండిషన్స్ కన్సిడర్ చేసినప్పుడు మనం స్టాయికియోమెట్రీ ఆఫ్ ద రియాక్షన్ ని కన్సిడర్ చేయాలి. అంటే ఇంపార్టెన్స్ ఉండదు, ఎందుకంటే అన్ని 1m కాన్సన్ట్రేషన్ లోనే ఉంటాయి. కాకపోతే it is not E naught value, it is E value. Okay, that's a conclusion we can make. Okay, so what you can write? Therefore put it in a block, standard cell potential, in brackets E naught cell, is independent of the stoichiometry of the reaction. That's the conclusion. That's, I think, what's the point there? 30, point number 30. Fine. Okay. Next. Now, whether a particular reaction is feasible or not, spontaneous or not, can be predicted by taking the E output can be positive or negative, can be predicted, and by calculating using these formulae, and I can know what will be the E cell and whether the reactions are spontaneous or not. Okay, now write. Is it point number 30 or 31? Point number 31. Hello. Point enta?
33, ma'am.
33 na? 31 lo
ఉంది
అనుకున్నా. Okay.
30, ma'am.
So right. Okay. Right. This. If E cell is positive, reaction is spontaneous. And cell is galvanic or voltaic cell. If E cell is negative, reaction is non-spontaneous and cell is electrolytic. Okay, cell is an electrolytic cell. If E cell is equal to 0, reaction is at equilibrium and there is no net electrical change. No, neither power is supplied or power is generated. So reaction is in equilibrium. That means the cell is dead. It's a dead cell. Okay, this is an important one. You need to keep it in mind. You need to keep it in mind. Okay. Next. Okay. Next point. ఇక్కడ దాకా clear ఉంది కదా? So when you're talking about the E cell values, okay, and you're predicting the spontaneity of a particular reaction and you're just predicting whether it is going to be a galvanic or voltaic cell. Okay, I'll get back to a point. So what is happening during this transformation? That means a chemical reaction is taking place. Okay, then let me put this. You have your mobile batteries. Okay, so are they galvanic cells or electrolytic cells? Roll number 60. Roll number 61. Good morning. Good afternoon. 61 is absent. 71. 71 is also absent.
Ma'am, present, ma'am.
Roll number 71 is present.
Yes, ma'am.
Okay. Dikshita.
Yes, ma'am.
What's your the cell, your mobile battery, lithium ion battery?
Yes, ma'am.
Is it a galvanic cell or an electrolytic cell, or it is both?
Ma'am, maybe electrolytic.
నువ్వు మేబీ అని చెప్పకు, నీకు తెలుసు, నీకు చెప్పు, సరిగ్గా అప్లై చేయి బ్రెయిన్. అది ఎప్పుడు ఎలక్ట్రోలైటిక్ అని ఎందుకు అంటున్నావు? Deepika, get the answer. 1 second, I'll tell you. Your friend next, your friend would explain and just listen with concentration. You'll answer it again for me. Okay. Roll number 81. Good afternoon.
Good afternoon, ma'am.
Roll number 81. Good afternoon. Are you there? 81.
Yes, ma'am.
Chupanana. What's the answer, Harshit? What's your answer, Harshit? Your mobile battery, which is a lithium ion battery, is it A? Galvanic cell or an electrolytic cell? You need to be fast. Come on, come on. Or is it both?
Electric energy to both, ma'am.
Both. Good.
Yes, ma'am.
That's it. Already in bold. Sal cheppan me andarki. It is both. Okay. When it is acting as electrolytic cell.
While discharging, madam.
Electrolytic cell ఛార్జింగ్ ఉన్నప్పుడు ఎందుకంటే నువ్వు ఛార్జింగ్ పెట్టినప్పుడు ఎలక్ట్రికల్ ఎనర్జీ ఇస్ గెటింగ్ కన్వర్టెడ్ టు కెమికల్ ఎనర్జీ. ఓకే, సెల్ రియాక్షన్ ఈస్ నాన్ స్పాంటేనియస్. సరే, ఓకే. వెన్ ఇట్ ఈస్ యాక్టింగ్ యాస్ ఎ గాల్వానిక్ సెల్,
డిశ్చార్జింగ్ మేడం.
డిశ్చార్జింగ్ అప్పుడు కరెక్ట్.
స్పాంటేనియస్.
ఓకే, ఓకే, స్పాంటేనియస్. దట్ మీన్స్ sometimes E cell is positive and sometimes E cell is negative. Is it possible?
Yes, ma'am.
Okay, correct. And such cells are called as reversible cells. Okay, so what are reversible cells and what are irreversible cells? Okay, so reversible cells are those cells in which the cell reaction takes place in both the directions. That means reactants react to give products and the products again give back reactants by supplying energy little more than the EMF of the cell. Such cell reactions are called as reversible cells and the cells are called as reversible cells. And by using such reversible cells, I can make secondary cells like our mobile batteries or our laptop batteries, etc. Okay, those batteries or those cells in which the cell reaction is irreversible, that means it takes place in a single direction and the products do not give back the reactants even after supplying the electrical energy, are called as irreversible cells. The cell reaction is irreversible cell reaction and the batteries are called as primary cells. Okay, is the point clear? Is the point clear to you all? Okay, so is about the reversible cells and irreversible cells. Okay, so what are reversible cells? Right, the next heading, point number 34. Point number 34. Reversible and irreversible cells. Reversible and irreversible cells. Right. The cells in which the cell reaction proceeds, the cells in which the cell reaction proceeds reversibly are called reversible cells. Are called reversible cells. Right. Point A. Reversible cells. Reversible cells. In these cells, reactants spontaneously combine to give products and electrical energy. Reversible cells. In these, reactants combine spontaneously to give products and electrical energy. and act as galvanic cells and act as galvanic cells by supplying energy little more than the cell EMF, by supplying energy little more than the cell EMF, products combine to give back reactants. Products combine to give back reactants. And the cell acts as electrolytic cell. And the cell acts as electrolytic cell. Example, all secondary batteries like lead acid batteries, lithium ion batteries, etc. Next, irreversible cells. Irreversible cells. The cells in which reactants combine to give products and electrical energy and the reverse reaction is not possible. And the reverse reaction is not possible. Such cells are called irreversible cells. Such cells are called as irreversible cells. And example, all primary batteries. All primary batteries. Okay. So that's about the E cell values and the primary cells, secondary cells, and know-how. Okay. Now I'll write an important one. If temperature is not equal to 25 degrees centigrade or concentration of electrolyte is not equal to 1 m, then the conditions are called as non-standard conditions. Okay, and in such cases, how to calculate the electrode potential, the single electrode potentials? That means if Zn plus 2 slash Zn is equal to minus 0.34 volts, when the concentration of Zn plus 2 is 1 m. Okay, if the concentration of Zn plus 2 is 0.1 m, okay, then what is going to be the E value? It is not E naught now. Why? Because obviously It is non-standard condition. Now, how to calculate the E values or the single electrode potential values under non-standard conditions? You have any idea?
Next equation.
Nernst equation. Nernst equation is one equation. Actually, this scientist called Nernst have studied the equilibrium conditions of various systems, and he brought about this equation called as Nernst equation. So, before I proceed going about the derivation of Nernst equation, which is very much there in your syllabus, I have a small question for you. Now, if there is EMF, there is flow of charge. Now, how much charge is flowing between any 2 points, anode and cathode? Now, always there is flow of charge from anode to cathode. Correct? Is the symbol correct? Okay. Now, how much charge is being flown from anode to cathode? Is there some work done? Okay. Now, to get one mathematical expression for all what all I'm asking you, then I need to tell about the connecting link between the thermodynamics and electrochemistry, which speaks about the calculation of the E values and its quantity. Okay, and what is the thermodynamics of it? Okay, then I'll say rusting of iron is also a spontaneous reaction. But do you expect to build a battery taking the rusting of iron as one of the parameter? It is foolish, madness, I'd say. Is it not? So we'll always talk whether the reaction is feasible or not. Okay, that is all studied under thermodynamic studies. Okay, so how to correlate between the thermodynamics of our batteries and the feasibility of reactions? One point I understood by this time is that when I'm building a battery, I'm always considering that the cell reaction is spontaneous. So the cell reaction is spontaneous and it is giving net heat energy, which I converted into electrical energy by building electrodes. Very good, fine. So after doing so, how to calculate the net output? Okay, how much work has been done during this generation of electrical energy? That means the charge has flown from anode to cathode. So how to calculate that? So that's going to be equal to NFE. And every time, if there is a decrease in the free energy, okay, then I always know such reactions are always spontaneous in nature. So whenever the system's free energy is decreased, then such reactions are always spontaneous reactions. So that's a correlation between the electrical energy and the thermodynamics of an electrochemical cell. Okay, so what's going to be ఇది అర్థమైందా? ఇప్పుడు స్ట్రెంగ్త్ పెరిగిపోతుంది, అటెండెన్స్ తీసుకునే టైం వచ్చింది. సో అందరూ వచ్చేస్తున్నారు అటెండెన్స్ కి. 40 కాస్త 45 అయిపోయింది. ఇప్పుడు నేను చెప్పిన కాన్సెప్ట్ అర్థమైందా? ఏం చెప్పాను? రైట్ ద హెడింగ్. Write the heading. EMF of a cell. EMF of a cell and free energy. EMF of a cell and free energy. So what I'm talking? EMF of a cell and free energy. So what I can say? Now this equation, which what all I am right now telling you, is the connecting link between thermodynamics and electrochemistry. So cell potential, or which I'll call it as EMF, and free energy. Okay, so free energy means gives free energy. Okay, so what I know, okay, whenever there is decrease in free energy, the reactions are spontaneous. And non-spontaneous reactions include a positive value for free energy. But what it is corresponding here, that whenever there is decrease in free energy, the reactions are spontaneous, but delta E is always positive. Here, delta E is negative. Is the concept clear? Ardhamainda? Do you accept this? That what happens to you when you don't eat and work? Okay, you're extending energy spontaneously. Okay, then what is happening? Your free energy is always getting reduced. So in a spontaneous chemical reaction, okay, there is always delta E, which is positive, and delta G is always negative, and vice versa. Okay, that means they are in inverse proportion. That's the first one. Okay, and what is happening? Work is done due to transfer of charge from anode to cathode. What is happening? Work, when charge is flowing from anode to cathode, some amount of work is done. So how much work is done? That will be equal to decrease in the free energy of the system. Okay, and that is going to be equal to minus delta G is equal to work done, that is equal to NFE. That's the equation of thermodynamics, or delta G is equal to minus NFE, where N is the number of moles of electrons that are flown from anode to cathode. F is the number of farads, that's a charge, and E is the EMF of the cell. Okay, to understand this, I'll need to ask you a few things and again explain. Okay, so what's your idea now? Charge is flowing spontaneously from anode to cathode. ఇది యాక్సెప్ట్ చేస్తారా అందరూ? ఏమవుతుంది? స్పాంటేనియస్ కెమికల్ రియాక్షన్ అవుతుంది, చార్జ్ ఏమవుతుంది? యానోడ్ నుంచి క్యాథోడ్ కి ఫ్లో అవుతుంది. ఓకే, గుడ్. సో ఎంత చార్జ్ ఫ్లో అయింది నేను క్యాలిక్యులేట్ చేసుకోవాలనుకో ఏం చేయాలి అంటే చేంజ్ ఇన్ ద ఆక్సిడేషన్ స్టేట్స్ కనుక్కోవాలి రెండు పాయింట్స్ దగ్గర. సరే, ఓకే. గ్రేటర్ ద పొటెన్షియల్ డిఫరెన్స్ ఏమవుతుంది? మోర్ ద charge keeps flowing. Okay, so how I'll calculate the net amount of work done? By taking this formula, NFE, NF, that is the total amount of charge that has flown between the two electrodes separated by the EMF of E volts. And what I realize is that if E is positive, G is negative. G is positive, E is negative, and hence that's the relation between the cell potential and free energy. It is given by the mathematical expression delta G is equal to minus NFE. Okay, understood? Right. Next point, point number 35. Okay, so what you can write? When a spontaneous chemical reaction is taking place, when a spontaneous chemical reaction is taking place, when a spontaneous chemical reaction is taking place, charge flows from anode to cathode. Charge flows from anode to cathode. Anode to cathode, full stop. The amount of charge flowing is directly proportional to the amount of charge flowing is directly proportional to the potential difference, capital E, between the two electrodes. The amount of charge flowing is directly proportional to the potential difference or EMF, okay, between the two electrodes. Okay, next point. The net amount of work done during this operation can be mathematically represented by the equation minus delta G is equal to work done is equal to NFE where E is equal to EMF of the cell or potential difference between the electrons. F is equal to farads, which is nothing but 96,500 coulombs charge. And N is equal to number of moles of electrons. N is equal to number of moles of electrons. Roll number 118. Good afternoon. Roll number 118 is present. 118. 119.
Yes, ma'am. Present, ma'am.
119. You are present.
Yes, ma'am.
Neeraj,
Yes, ma'am. Yes, ma'am.
did you understand what I've told? అర్థమైందా లేదా? తొందర చెప్పాలి.
Just somewhat
understood?
understood, ma'am. Somewhat
Huh?
understood, ma'am. Somewhat understood, ma'am.
Somewhat understood. సరే అయితే ఆపే. Okay, I have a question. You have done 3 examples. Okay, I've given okay, right. Did you write till this point? Right. The question. Given 3 cells constructed by taking standard conditions. Given 3 cells constructed by taking standard conditions. Cell 1, zinc copper combination. Cell 2, cell 2. Cell 2. Iron, lithium. Iron, lithium. Cell 3. Silver, copper. Predict which cell has greater output or maximum output. Two, 6, 21. 61, 61, 62. Answer your roll call. 62,
62. Yes, ma'am.
63,
Yes, ma'am.
64,
Present, ma'am.
65,
Present, ma'am.
66,
Present, ma'am.
67,
Present, ma'am.
68,
Present, ma'am.
69,
Present, ma'am.
70,
Present, ma'am.
71.
69%.
Huh?
Present, ma'am.
69 present, ma'am.
72,
Present, ma'am.
73,
Present, madam.
4,
Present, madam.
75,
Present, ma'am.
6,
Present, ma'am.
7,
Present, ma'am.
8,
Present, ma'am.
78,
Present, ma'am.
79, 80.
Present, ma'am.
Okay. Roll number 80. ఎవరు?
Present, ma'am. 80.
ఓకే ప్రజ్ఞ చెప్పు నాన్న
Ma'am.
ఎక్కడ ఈ సెల్ మాక్సిమం ఉంది
Ma'am, E cell.
మాక్సిమం ఏ కాంబినేషన్ లో ఉంది జింక్ కాపరా అయన్ లిథియమా లేకపోతే సిల్వర్ కాపర్ కాంబినేషన్ లో మాక్సిమం అవుట్పుట్ ఉందా
Ma'am, iron and lithium.
అయన్ లిథియం ఎంత ఉంది ఈ సెల్ వాల్యూ ఎంత ఈ సెల్ వాల్యూ
Ma'am, 2.61 volt.
2.61 is she correct
Yes.
Yes, ma'am.
అయితే కాపర్ సిల్వర్ కంబైన్ చేస్తే ఏమైంది
The value, ma'am,
ఆ,
0.46 volt.
0.46 ఉంది అదే ఐరన్ కాపర్ కంబైన్ చేస్తే ఎంత ఉంది 1.1 volts ఓకే సో బై దిస్ టైమ్ వాట్ డిడ్ యూ అండర్స్టాండ్ అంటే ఆ టూ ఎలక్ట్రోడ్స్ మధ్య ఎస్ఆర్పి వాల్యూ డిఫరెన్స్ ఎక్కువ ఉన్న కొద్దీ ఏమవుతుంది వాట్ ఈస్ హ్యాపెనింగ్ ద ఈ సెల్ వాల్యూ ఈస్ కరెస్పాండింగ్లీ ఇంక్రీసింగ్ am I right or wrong okay so in which case maximum electrons have flown from anode to cathode roll number 81 81 is absent 82
Madam.
81 is present
Yes, ma'am.
హర్షిత్ ఇప్పుడు చెప్పు నాన్న ఇప్పుడు ఏ ఏ ఏ బ్యాటరీలో ఏ సెల్ లో మాక్సిమం ఎలక్ట్రాన్ ఫ్లో ఉండింది యానోడ్ నుంచి క్యాథోడ్ కి లిథియం ఐరన్ కాపర్ సిల్వర్ దాంట్లోనా లేదా జింక్ కాపర్ దాంట్లోనా ఎనీవన్ హూ కెన్ ఆన్సర్ ఫ్రమ్ ద క్లాస్
Iron lithium.
Iron, lithium.
iron lithium roll number 98 are you present roll number 98 is absent 108. Absent. 118.
Present, ma'am.
Evaru present?
118, ma'am.
Sujit, tell me. In which case there is maximum electron flow from anode to cathode? Why, Sujit?
Yes, ma'am.
What is the last sentence I've made you write?
Ma'am, I have poor net connection. I in middle and middle, ma'am.
మిడిల్ అండ్ మిడిల్ అయినా ఇప్పుడు నెట్ కనెక్షన్ ఎలా వస్తుంది సుజిత్?
Really, ma'am. I have joined it first and in middle and now, ma'am.
Okay. Sorry. Fine. I trust
Ma'am.
you.
Yes.
Okay. Roll number 82.
Yes, ma'am.
83.
Yes, ma'am.
84.
Present, ma'am.
85.
Present, ma'am.
86. 86. 87. 88.
Present, ma'am.
89.
Present, ma'am.
90. 91. 92.
Present, ma'am.
93.
Present, ma'am.
94. 94 is absent. 95.
Present, ma'am.
96. 97.
Present, ma'am.
98. 99.
Present, ma'am.
100.
Present, ma'am.
1.
Present, ma'am.
2.
Present, ma'am.
3.
Present, ma'am.
4.
Present, ma'am.
5.
Present, ma'am.
6.
Present, ma'am.
7. 7. 8. 9. 10.
Present, ma'am.
11.
Present, ma'am.
12.
Present, ma'am.
13.
Present, ma'am.
14.
Yes, ma'am.
15. 16.
Yes, ma'am.
17.
Present, ma'am.
18.
Present, ma'am.
19.
Present, ma'am.
20.
Present, ma'am.
So I'll conclude now. It's already late. By 7 minutes. So in which case you're expecting maximum electron flow? ఎప్పుడు max EMF ఎక్కువ ఎప్పుడు వస్తుంది? రెండిటి మధ్యలో ఎప్పుడైతే పొటెన్షియల్ డిఫరెన్స్ ఎక్కువ ఈ సెల్ వాల్యూ వస్తుంది. అంటే ఎక్కడ ఏ కేసులో మాక్సిమం ఎలక్ట్రాన్ ఫ్లో ఉండింది? కాంబినేషన్ ఆఫ్ లిథియం అండ్ అయాన్. సరే, సో ఈ కాంబినేషన్ లో అంటే పొటెన్షియల్ డిఫరెన్స్ ఎక్కువ ఉంటే రెండు ఎలక్ట్రోడ్స్ మధ్యలో ఎక్కువ చార్జ్ ఫ్లో అవుతుంది, అందుకని ఎక్కువ ఈఎంఎఫ్ ఇస్తాయి. ఓకే, సో ఈ వాల్యూ ఎంత చార్జ్ ఫ్లో అయింది? ఎన్ఎఫ్ అంత చార్జ్ ఫ్లో అయింది అనమాట ఈ టూ ఎలక్ట్రోడ్స్ మధ్యలో. ఓకే, సో మొత్తం ఎంత వర్క్ డన్ అయింది, ఎంత స్పాంటేనియస్ రియాక్షన్ అయింది అనేది ఈ మ్యాథమెటికల్ ఎక్స్ప్రెషన్ యూస్ చేసి కనుక్కుంటాం. మైనస్ డెల్టా జీ ఈజ్ ఈక్వల్ టు వర్క్ డన్ ఈజ్ ఈక్వల్ టు ఎన్ఎఫ్ఈ. అంటే ఒక ఈ సెల్ వాల్యూని తీసుకుని నువ్వు క్యాలిక్యులేట్ చేస్తాం అనుకున్నప్పుడు నువ్వు క్యాలిక్యులేట్ చేసావు ఈ సెల్ వాల్యూస్ అన్నిట్లో. అంటే నువ్వేం రియలైజ్ అయ్యావు? ఈ టూ ఎలక్ట్రోడ్ కాంబినేషన్స్ లో ఎప్పుడైతే సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్స్ ఆఫ్ ఇండివిజువల్ ఎలక్ట్రోడ్స్ ఎంత ఎక్కువ డిఫర్ అయితే అంత నెట్ ఈ సెల్ వాల్యూ వస్తుంది. అంటే ఎందుకు అంత ఎలక్ట్రాన్స్ ఫ్లో అవుతున్నాయి అనమాట యానోడ్ నుంచి క్యాథోడ్ కి. అది ఎలా క్యాలిక్యులేట్ చేస్తాను? నెట్ అమౌంట్ ఆఫ్ ఎలక్ట్రాన్ ఫ్లో ఫ్రమ్ యానోడ్ టు క్యాథోడ్ అంటే ఈ మ్యాథమెటికల్ ఎక్స్ప్రెషన్ యూస్ చేసి ఎన్ఎఫ్ఈ. అంటే ఎన్ని మోల్స్ ఆఫ్ ఎలక్ట్రాన్స్ ఉంటాయి యానోడ్ నుంచి క్యాథోడ్ కి అంటే n మోల్స్ ఉంటాయి. ఆ n మోల్స్ ఆఫ్ ఎలక్ట్రాన్స్ ఎంత చార్జ్ క్యారీ చేసి ఉంటాయి? f is nothing but farads అంటే ఫారడే అమౌంట్ ఆఫ్ చార్జ్ 96,500 కూలమ్స్ చార్జ్ ని అవి తీసుకెళ్ళాయి. అంటే బిట్వీన్ వాట్ ఈస్ ద పొటెన్షియల్ డిఫరెన్స్, ఎలక్ట్రోడ్ పొటెన్షియల్ డిఫరెన్స్ ఎంత? ఈ వాల్యూ అంత. సో అంత చార్జ్ ఫ్లో అయిందనమాట యానోడ్ నుంచి క్యాథోడ్ కి. అండ్ దిస్ ఎక్స్ప్రెషన్ ఈస్ ద కనెక్టింగ్ లింక్ బిట్వీన్ థర్మోడైనమిక్స్ అండ్ electrochemistry. It speaks about the feasibility of that redox reaction, okay, how spontaneous it is and how much amount of work is done during the process. Okay, that's the one. So tomorrow we'll derive Nernst equation based on this cell potential and free energy values. Okay, good day.